we're back. I hope. Who knows? We're going to keep going until somebody complains on the live stream saying that they can't see nor hear us, but that is okay. So I have Bob Denny down here. He's below me. I'm the guy at the top, unfortunately. For those of you who do not know who Bob Denny actually is, he is the guy that made ASCOM a thing, and he is also the guy behind DC3 Dreams. So if you guys don't know what DC3 Dreams is, please, please, please have a look at what those guys have to offer, because this is what keeps him alive. And no, he does not work at Denny's. It's just by name by association. So, Bob, take it away. Give us some information about you.
Okay, I will do that. Good afternoon, good morning, good evening, wherever you are. As Simon said, I'm Bob Denny. My talk this afternoon or today is on ASCOM and ASCOM ALPACA. And you see the title. Let me give you a little bit of background on me just quickly. As Simon said, I'm the guy who thought up the idea of ASCOM, which you'll learn more about, probably more than you ever wanted to learn by the time we're finished here. I'm not an ASCOM developer anymore, although I did that for 9 years. I'm just an astronomy app developer. We sell our software, which is an observatory operating system, and I'm not going to say anything more about it right now. You can go to dc3.com and find out more. And it's just that simple, dc3.com. All of my ASCOM activities are voluntary, and I'm not compensated at all. So I'm just here now as a flag waver for ASCOM and to help people understand what's going on. One thing I'm not here for today is a standards war. There are other connectivity options out there. I'm not going to get into comparing or any of that. ASCOM's a totally successful specification, and you'll see more in a minute, but it is totally successful as a standard. I'm here to cover the purpose of ASCOM, what ALPACA does to extend it past Windows, and I'm not here to defend it against other standards. So just to keep that in mind. Before we do anything else and we get into the ALPACA part, I'm going to talk a lot about ASCOM as fast as I can get through it, just to give you a technical background of what it is and why it exists and how it works at a very, very shallow level. But fundamentally, you hear people talk about, well, it's that ASCOM, ASCOM's broken and so forth. What ASCOM itself is it's a set of specifications, a set of libraries that are used by developers to implement applications and control software that talk to each other over a universal interface. And the things that you see come from your application developers and your device developers. What you use is software that comes from your mount makers, your focuser makers, your planetarium makers. Those are the people with whose software you interact. ASCOM is just plumbing, basically. My purpose today is to help you become more knowledgeable, to understand how it works so that you can see how it fits into the big picture. What we're going to go through today is first talk about what's called driver client. This has been around in computing for 60 years, let's say 50, since the 60s, so late 50s, early 60s. You need to understand what this is and why it's important for our industry and for our ecosystem. And then I'm going to talk about the principles of the interfaces and what an interface is, very briefly. A little bit of history, then I'm going to go right into ALPACA and talk about what that is and how that extends the reach of the universal interfaces out beyond Windows and provides already interoperability between Windows and other platforms. A little bit about the current status, and then we'll wrap up. I'm not going to cover cameras and camera standards, again, because that whole area is in flux. We were just talking about that offline before I started here. It's a hot button topic, and it's just something I need to stay away from so that you can understand what's going on with everything else in astronomy and not cameras. All right. Also, I'm going to try to provide spots in here, but I'm going to watch my time. And I may or may not. I don't know if Simon, do I have an hour or do I have an hour and 15 minutes? I don't know which, and I'll modulate my thing.
Because you're last, not done by on purpose, you can actually theoretically go as long as you want. But
all right, then I'll if there's
put your
any
own time limit
questions
on there.
How about this? If you see any really hot questions that really need to be answered to move on, I have these breaks like this scattered throughout the presentation so that people who type in questions, if you happen to see one that you think I should stop for, when I hit one of these slides, ask me the question and I'll answer it. That's the best way then. And
Awesome.
Towards the end, I'll try to answer as many until everybody gets sick of it or you run out of patience or whatever.
Yeah.
How's that?
Yeah. Although I'm going to put you on the spot at the end of the talk, because I know you haven't prepared for what I'm going to ask you later, but we will get to that point, and I know you're going to answer it because
I love off-the-wall questions. That's my favorite thing.
Awesome.
All right. I talked a little bit about driver-client architecture. This is a concept in computing that's been around forever. In computing overall, you have two basic systems. In fact, this is true of engineering in general. You have two ways to approach a complex system. One would be a single vendor model where everything in the system is from one company. Let's say you had an airplane. You had a big giant black box in the belly with 1,000 Canon connectors hooking up to the toilet, the lights, the entertainment system, the autopilot, the engine controls, all in one giant black box. The box, the airplane, the tires, everything would be made by one company. That would be a single vendor closed system where there's no way that you can mix and match pieces. The other way to do it is to have a multi-vendor open system where the tires fit because the tires are a standard with regards to the wheels, and the brake shoes are a standard to the brake system, and everything is based in the airplane on standards and interfaces that everybody agrees on. USB is an interface standard. Ethernet's an interface standard. The plug on your wall is an interface standard. So the idea behind driver client is you have an application that uses things, and the things have a universal interface. The purpose of ASCOM is to provide that universal interface. It is really important to understand why that universal interface is advantageous, and it allows you to buy different pieces. PhD would not exist if it weren't for universal interfaces. It would be part of some big monolithic system. Sequence Generator Pro, for example, it would not exist if it weren't for ASCOM universal interfaces. They could not have written software in practical time and support all of the devices out there that they talk to, every mount and all of that. So that's the reason for a universal interface. What happens with Alpaca is it extends that universal interface out into the rest of the platforms out there by changing the way that the pieces communicate with each other without changing the interface. And I'll try to explain this better or in more detail. And I hope this presentation is going to be available to you because there's a lot of words here. I'm not a bullet reader, so I'm sorry, but that's it. So here's where we all started. Everybody was just stringing things together, plug in RS-232, try to make this thing talk LX200, but that's not really a standard. It was kind of like the old Hayes modem standard, if you remember, AT, sharp, blah, blah. Yeah, it's not a good way to do things. And so here's where we started. Before driver client, and this is where it gets really, where you really want to try to zero in on this. Before driver client, what would happen is a particular program would have to write their code to support each one. In this case, we'll say this is a planetarium or something. That planetarium would contain special code for each of the types of mounts that it supported. So you remember the old days, does your program support the Wiebelfetzer 62 mount? That question came up because all these programmers had to write their own code to support that Wiebelfetzer. Well, the Wiebelfetzer guy may or may not have published a very good spec for it. So it becomes an effort. And that can grow into completely, NP complete problem, right? It's a XY matrix problem. It just grows forever. Then you have the problem of what came out 10 years ago and the stuff that comes out next week. What do you do when it comes out and you don't have code for it? Think about that. So you end up with a situation where each program that comes out on the market has to put their own stuff in there to control each mount. And this is just for mounts. Add all the other types of devices into this, and you see it becomes ridiculous. In this case, you have 3 programs here, SkyWizard, StarView, and Amazing Night Sky, and you have 4 mounts. Well, the SkyWizard programmer, the StarView programmer, and the Amazing Night Sky programmer each have to write their own code to support the A mount, the B mount, the C mount, and the D mount. And each of those guys, the mounts have their own programmer doing the firmware. Can you see how this gets out of control really fast? So if you want an open architecture where people can come in and innovate and go in, you really need to have a universal interface. But there's one more thing people don't think of when they think of the old ways. Let's say you have your program, your wonderful planetarium program, and now I have problems with this B mount. It's misbehaving. It crashed into the pier or it did something, well, where's the problem? I pushed slew and then it went crazy. Where's the problem? It could be that the code written by SkyView, that developer, has a bug, or it could be the firmware of the B-type mount guys, or it could be the connection. Probably, though, it'll be if it's a software error, you don't know where it is and you end up with finger pointing. Well, it must be this. Well, I didn't do that. It must be this. So you don't know where the problem is, and you end up now multiply that by more programs, more mounts, and more weird things, and you can see where this is going, that it gets really impossible. One more click. Okay. Now, let's look at what happens when you have a universal connection, where all the mounts act just the same. They all have the same functions. They all have the same behavior. Now, I'm Mr. SkyView. I write one set of code, the standard ASCOM code. It will handle all the mounts that have come out in the past and all the mounts that will come out in the future if the mounts come with a driver. The driver's job is to implement that standard universal set of functions. So me as a developer, I write my code for the application and I write it and I call those standard functions, and I can plug any kind of mount I want in and control it. Even the ones that come out next week or next year, if they come with ASCOM compatibility. And now let's look at what happens when you have a problem. Because I've written my code in SkyView or whatever to speak the standard calls, if I have a problem in my code in the application, it's broken for all the mounts, right? So people show up at my doorstep with pitchforks and torches and they say, your telescope control is bad, but it's not mount specific. However, if I'm working successfully with 10 mounts and then one type of mount I'm having a problem with, where's the problem? No finger pointing, it's in the mount or the driver. So you've already split things apart in such a way that you can identify where the problem is, which isn't half the issue. So this really makes a huge difference in being able to manage modular systems, and we all use modular systems. So I'm hoping that this gives you some clue as to why the universal interfaces and modular construction is a better way to go, especially for more complex systems. Do you see any standout questions, Simon? If not, I'll keep cruising. I don't hear your voice.
The funny thing is, the question that somebody did actually ask is what I'm going to ask you right at the end, because it's related to that. It's just funny how that person clocked onto something right off the bat.
That's good. That actually means it clicked, something important clicked in their mind, and I'm happy about that. All right, off we go. The next thing I'm going to talk about is, well, okay, we've got these universal interfaces. What are their characteristics? What makes ASCOM what it is compared to all of the ways that you could do this? The key here is that the set of functions for a particular type of device, and I'm going to stay with mounts just as an example because that works. The functions such as slew, sync, park, those type of things are the same, and they are the only functions. The key here, and this is really important, at the last bullet is the key here. It's for routine operations only. And this is so important to understand. The ASCOM interface is to take care of the stuff we do every night. It is not to expose Coolio gadgets for making the telescope point better or slew faster or slower or whatever. All of that is engineering details that is mount specific. Some people use encoders and servos, other people use worm gears and PEC. However they do that to make the telescope do a better job, ASCOM assumes that you have a perfect device. If I tell you slew here, the best telescope that you could possibly get would slew within a millionth of an arc second of that location, right? And it would track the sky within a millionth of a microsecond second of the sidereal time. That would be perfect, but no scopes like that. So how they do that and make themselves better is their business. ASCOM's business is to tell the mount to do what I needed to do to accomplish my astronomy, and that's it. Slew, expose, move, expose for a camera, and so forth. So that's the way that ASCOM is designed. Routine operations only, and the set of functions is pushed towards minimization. The design is to minimize the number of those functions and hit only those very things that you really need. There are other designs where they just balloon into more and more stuff. Well, I need to have PEC control, or I need to be able to do this, this, and this. Well, okay, fine, provide it. But it's going to be different from your mount to the next mount to the next mount. We don't do that. So that's a key thing. It's a fixed set of objects and actions. It's minimal, and the behavior of each of those objects and actions, that are the objects are things like right ascension, declination, those are the things, and the actions are slew, park. So each one of those is strictly defined behavior-wise, and I'm going to show you later how that's done for the telescopes as a tool. Remember I said ASCOM also includes tools for developers, how that's done. The optional features that you can have are done by looking at can flags. Can this slew to Altaz? Some mounts can't, some mounts can. So there's a flag you can read. If this mount can do that, then it's fair enough. You can call those functions. So that ASCOM dictionary, it changes only under great review and acceptance. And it is backward compatible. It's the telescope commands that were there in 2000 are still there, and they still behave the same. So you're not going to get the rug pulled out from under you by a new ASCOM platform. And that's probably the number one goal of the group. So let's look at a validation process that a developer can do on a mount with the tool that comes with the ASCOM platform. This should start a video anytime soon. Let me click here one more time. There it goes. Okay, so this is the report from the conform tool that any developer who develops a mount and then a corresponding driver for that mount can run against the mount. And if you look here, you'll see the extreme detail that is tested. And so there have been so many, the funny thing about this over the years, people always, when they read the specs, they try to interpret the specs in a way that minimizes the amount of work they have to do. Here's one where a bad azimuth coordinate was sent to the mount, and it has to reject that. If it doesn't, it fails the confirmation test. So and there's a bunch more tests like that, as you can see. So, and the developers have this tool available that's made available. Peter Simpson wrote this thing, and it is just fabulous. So if you can pass this conform test, your behavior, remember I said the behavior is as important as the set of functions, your behavior is going to be close to right. Now, look at this. I've had this conversation with people. Again, this goes to the design of the interface. And they go, well, you know, things are getting more complicated. You need to add more things to it. And things are getting more sophisticated and so forth. Well, this is what you would end up with if you listen to those people. You would end up with something like this for your interface, when really what people expect going into the future is more like this. The more sophisticated something gets, the more it should unburden you from having to push buttons, twist dials, and do things. The stick shift is gone, the clutch is gone. You know, on the Tesla, you don't even need the brake half the time. So it is that kind of minimization that's part of the deal, and it creates some interesting conversations. But we have, for the last 20 some odd years, managed to keep it clean. So once again, here's another breakpoint. We've now talked about the interface principles. Anything that is a standout, Simon?
Yes.
Okay.
ETA for when Alpaca cover features will be released.
Alpaca what features?
Cover features.
Cover features.
I'm not sure what that means, but
I'm not sure I know what that means. But let me get into the Alpaca part. And I will talk about the status of Alpaca. That actually, if I go to my next slide, section 5 will be current status of Alpaca. There's stuff that's out there now, and you'll see what that is. And there's no ETA because, again, ASCOM isn't a thing. It's a set of specifications and tools. So if you want something that implements Alpaca for what you want it for, you have to go talk to the programmers that develop your mounts or your focuser or whatever, or the application developers. And there have already been several of them who've already integrated Alpaca into their apps, and I will talk about that. Let me zip through just a touch more history. I'm up to 30 minutes now, so I'm running right on time. This won't take long. This is the history of ASCOM starting in 1999. I don't ask me how I ended up here, but I looked out at the astronomy ecosystem out there, and I said, wow, there's a couple of closed systems, and there's a bunch of homebrew grad student ware out there. This is not going to go anywhere. The only way I'm going to be able to enter this market, and anybody else, is if there's a set of standards for interface between applications and devices. And so that was part of what I did. Boy, it was a long, hard fight. 5 years. There was some acrimony, name calling, things that you would not believe how difficult it was. But by the end of 5 years, it was starting to catch hold. And by 2009, 2010, that would be 10 years later, it was and still is firmly ensconced as a standard in astronomy. So what's happening now is we're doing the same thing, but going out beyond Windows. I'm going to zip right by that because there's so much more I could say there, but it doesn't really add that much to what I'm going to do. Same with this. We took a survey last year of 52 app and device developers to see how well the APIs, the standards, were covering their needs and whether they thought it would take them into the future. And you can see these numbers down here. The URL at the bottom is where you can find the survey results, both the summary and the raw results. And I'm going to give you the ASCOM portal, the webpage at the end of the talk, and you can go there and there's just tons of information in there about all this. So the big one is that 100% of our respondents, both app and device developers, could see the ASCOM interfaces continuing to take them into the future. So we hit the nail on the head as far as those designs are concerned. They're not asking for a bunch more things to get thrown into the pie. Let's see. Let me get my mouse over here. Click. All right. Here's one thing that happened last fall. the very popular Stellarium planetarium, it did not support ASCOM, and there was a lot of talk about that. And this guy, Gian, and I don't know his last name, he came out in October with a plugin for Stellarium that gave it connectivity to ASCOM. By December, we had things like this, and this came off of Cloudy Nights. Thanks so much for the improvement. You have made a great contribution to this hobby. Fellow astronomers everywhere will appreciate your efforts. People were dying to have that universal connectivity from Stellarium, and because the developer came from the Linux world, and there wasn't that, that capability with something like Alpaca, he just resisted it. But he had a plugin interface, and this guy did it, and the thing is just wildly popular. So that was a good thing. All right, now another question stop, because we're going to shift gears now and go right into Alpaca. No?
Michael Kidd did reiterate what he was talking about, but I know you're going to answer it when you get to that point. So I'm going to hold off just in case before he asks any other questions. I did get somebody who's texting me, because not everybody is watching on a laptop PC. There's some of them are on their cell devices, which they probably shouldn't be because they're supposed to be at work. But he did ask this: whose responsibility is it to write the ASCOM interface? I think they're referring to each mount.
There's a core developer group that handles the changes, which will always be the addition of additional things. There'll be no changes to the existing objects and actions. There's a core developer group. The organization of ASCOM, of the initiative, is described on the ASCOM site. There's a whole page devoted to each of the groups of people and what their roles are and responsibilities. The interface designs, though, very rarely get changed because they've stood the test of time. Being an interface negotiator in a former life, I'm the one who designed the very first set of interfaces. But for example, the telescope interface has gone through 3 revisions since my original design. So, and those were additions of functionality that needed to be done. And that was done by a small group of people. Trying to design things by committee is a loser. And you have to end up having people whose design philosophies match, but that can then bounce things off of each other and come up with the whole is greater than the sum of the parts type of decision-making process. The camera additions took 6 months. There was so much argument publicly, and we just let all that go. And then we contacted behind the scenes camera manufacturers, and then we met again and blah, blah, blah. And really, there are 4 people, myself, Peter Simpson, Daniel, Van Noord, and Tim Long. And those are the 4 that are doing that. So, okay, now we're going to go to Alpaca, which is why you all came here, I think. But I hope now you have an understanding of what ASCOM is and why it exists and why it benefits our community. So if you look at this slide, this is conceptually what the idea of Alpaca is. The Windows symbol on the left represents the current COM because it lives on Windows and uses a Windows communication system, which I'll get into, to communicate between drivers and clients. What Alpaca does is it takes the same actions and objects, the same interface definitions, and implements that in REST, representational state transfer, which is a internet protocol that rides on top of HTTP and uses JavaScript object notation as the payload. It's extremely widely used. Roy Fielding was one of the most transformational things in computing, was Roy Fielding's original REST work at USC. So that's, every language out there has it. So the REST API was defined to match the API that was the application programming interface, the ASCOM interface, one for one. So now on any of these platforms, you can communicate over TCP/IP, internet, I'll say not internet, but network. And it's the same interfaces, and the interfaces are 2/3 or more of the success or failure of any modular design. So we just took the super successful ASCOM interfaces and implemented them in REST. But that's not all. It's important to understand how all this ties together. And I'm going to make another statement after this slide, but this is really the money slide right here. So I'm going to spend a little bit of time on it. I've got some time. I'm only into this 37 minutes. So this is it. So if you're taking your COVID-19 training, which I saw on somebody's comment, this is so much more interesting than my COVID-19 training. So if you're doing that here, watch this. On Windows, there's your planetarium and your mount, and they communicate through the Windows COM LPC mechanism. That's what ASCOM does now. A one-line call in the language of the planetarium it gets called in there, and it gets transported by Windows and ends up in a function in the driver. So you're basically at a language level being able to communicate between two completely separate programs. And that's a magic thing about Windows. You can do that, and it's language independent. You can make the function call in one language, and the driver can be written in a completely different language. That's cool, but that's not on any other systems. And it's certainly not on any little ESP8266 chip things and Arduinos and all of that. So, but TCP/IP is, so that's where things went. So now, if you look here, that ASCOM remote gateway here today, that thing, I don't know if I have a pointer, and I'm scared. I tried to use the pointer in PowerPoint, and it froze my PowerPoint. So I don't want to use it.
We can see your mouse pointer moving
around. Oh, really?
So,
okay, yeah, wonderful. Yeah. All right, good. So this thing here exists today and more, which I didn't want to muddy the waters, but right now there are two ways that you can get from one to the from a program on Windows to use a device that is speaking Alpaca. For example, the Optec focus links right now runs Alpaca. It's a self-contained Wi-Fi device that as soon as you turn it on, you can locate it from your Windows application. And by the way, this Windows application has no changes. The developer of this planetarium did not need to lift a finger. The glue that's here is supplied as part of those libraries and tools that ASCOM 6.5 has, 6.5. And so today, a planetarium such as the Sky that has an ASCOM focuser interface can talk through today's existing platform 6.5 out over Alpaca and control the focuser that is self-contained. There's no USB, nothing. It can be Wi-Fi. It has a Ethernet also, because some places they don't like Wi-Fi, and so anyway. But the idea here is this whole thing is self-contained, and that exists today. So hopefully that'll answer half of the question of the previous question. But what about a planetarium, for example, on Linux that would like to use the Astrophysics APCC or Planewave PWI mount controllers, or all the other ones, EQMod, whatever, that run on Windows? That's obviously a less common situation, because most people who run Linux hate Windows and they wouldn't run anything on Windows, right? But there is the possibility of using Carte du Ciel and other planetariums, Hello Northern Sky, and one other that run on Linux and Mac, that already speak Alpaca and can talk through this gateway that exists today and talk to a Windows controlled mount, such as an astrophysics with APCC, or just their basic ASCOM driver, or the Gemini with the Gemini driver. And so it's on its way, basically. And it's important to understand, however, that I showed you this diagram, but it does not need to involve Windows. And this is so important. I've had the biggest problem letting people realize that the Alpaca protocols and interface definitions do not have anything to do with Windows at all. Yes, I need to go backwards here. Yes, they interface with Windows via this mechanism, but if you don't need Windows. There's nothing about Windows that needs to be present in a pure Alpaca environment. So a mount running on an Arduino can be used by an iOS app or an Android app or Mac OS or Linux with that same set of connectivity. There are no servers needed in between. There's no glueware needed. Everything takes place on internet. Well, network connections. So that's the key. One of the things that is we all know is how USB is such a pain in the neck. So if you were to make, and what we're hoping will happen in the medium to long term is, and it'll take a while, is the device makers will make Wi-Fi or internet connectivity for their devices. So you'd have a mount with a Wi-Fi on it, or a focuser with a little baby a processor, and they have, the Pi has Wi-Fi on it, right? So, and having that, and then being able to talk to your Linux box or your Mac with no wires. How cool is that? So any app in any language on any platform, everybody supports REST. No matter what language you use or what platform, you're going to find a REST library. So that's all you need. If you implement the strictly defined ASCOM interface as REST endpoints, which that everybody knows what a REST endpoint, developers know what a REST endpoint is, not just in astronomy, everywhere in computing this stuff is used. It's everywhere. So you define your ASCOM objects and actions as REST endpoints, construct them according to the documentation that's there now. You can talk across platforms, and it's there today. So what about security? Internet, oh boy, yeah, they're going to attack me from where, right? So it's designed to run in a sterile environment, not over the public internet. And that makes it makes things get much simpler. So you need to run your observatory not sitting across the public internet. Nobody does that anyway. It's like the worst of worst practices to do that. To go between the program, the planetarium, and the mount, with your planetarium in China and your mount in Chile. No, you would not ever want to do that, and have the low-level device stuff going out on the public internet. So this is designed to run in a sterile environment, which means if you need to use the WAN, it's up to you to provide the hardening for attacks of all different kinds that will protect your observatory. The government and educational institutions already mandate their observatories run in a sterile environment, and you probably should as well. So that's the thing there. Now, any questions that I can answer right this second?
Yes, this is actually a good one here. Is there a migration path documented to go from classic ASCOM to Alpaca?
Again, this is a function of the developers of the applications and the developers of the devices. There are tools that are being worked on right now to convert code that was written as a driver to run on Windows that could be ported over to Mac or Linux. This is a really squirrely situation. I almost, maybe I shouldn't even bring it up. It's being worked on as a tool that might be supplied in the future, but that basically would be something that you would take an existing driver that runs on Windows and then run that driver on the Mac, and change from COM to Alpaca. And then, because it would be an Alpaca driver on the Mac, all the COM speaking programs that run on Windows would still be able to reach that device and use it. That's the goal. But trying to move all of that, not only the language, the OS, and the underlying transport, and preserve code, that's a tough one. So it's really up to the device developers, the people who supply the devices, and the people who write the software to decide to use Alpaca as that communications and interface technology. Now, it's a chicken and egg problem, right? Should the device makers do it first, or should the application writers do it and then beat on the device developers? Right now, the app developers are ahead. They've already implemented it in 2 planetariums that run on Linux, and they're just sitting there now ready for anybody that comes along with an Alpaca device. So it's going to take a while. Keep in mind, the last ASCOM go around took 5 years just to take hold. But you got to start somewhere. And
I'm going to mention this, that there are companies right now that have produced devices, even in the long term, that will already support Alpaca. And I'm going to mention them right now so you guys can get a good idea. Is if you look at a lot of Optech devices, so for those of you who don't know who Optech is, Jeff Dickerman produces some of these really cool astronomy products. Now, I'm not going to turn around and say they're the cheapest things on the planet, but the biggest, more important part here is he solves that problem. And
Yep.
I know he's a huge advocate for ASCOM. And when he heard about Alpaca, more and more of his devices started to have the Alpaca functionality built into them. He knew, I mean, you guys talk anyway, so he knew ahead of time that when he was designing a product that this is going to be a necessity. Why not get on the band right now? The other company,
he's one of the pioneers, all right.
Well, I know he is. So interestingly enough, there is also another company out there that unfortunately they are a direct competition to Optech, is Prima Luce Labs, the Italian companies that make the Eagle. Their devices today, especially the eSATO focuser and the Sesta Senso 2 specifically, have this Wi-Fi functionality. They also have that TCP/IP protocol that can talk over Wi-Fi, Ethernet, etc., etc. So
I'm not sure that they're using. I think they may have a proprietary protocol on that, and I've talked with them about it, and I'm hoping that they'll see the light. And if they change over to Alpaca and use the same hardware in TCP/IP and Wi-Fi, they'll instantly be compatible with all the Windows software out there.
So I've been poking, I know you know who they are. I've been poking Omar about this, and I've said to them very specifically, you have to keep your eyes open and your mind open to all of this, because again, we're not starting a standard wars. And sorry, I don't want to digress into this big debate here, but we've got time. But I've already gone into this with a lot of manufacturers. You can't ignore the standard. You can't ignore this. You can't skip over this and create your own interface. This is probably, for us as end users, a big thing that we all need to work towards. And this is why we need people like you, Bob, to be the guy that stands forward and slaps him around the face one.
This has been putting my Alpaca or ASCOM and Alpaca hat on. Probably the number one thing is to watch people. They still have the idea that, well, if we invent our own protocols and we hook everything up our way, nobody else will be able to use it and we'll sell everything to them. That's not a success story and never has been in computing. And yet I still see it all the time. And so it it starts out well, but eventually they find themselves left in the dust by innovators who've come along and taken advantage of the openness of the infrastructure of the ecosystem. And they come in, and then now these cool add-on tools, PhD being a perfect example, there it is. Were it not for standard interfaces, if they had to write camera control software and mount control software, if they didn't have a pulse guide call for the mount, would PhD exist? I would bet you from Bruce that if they had to write control software for every mount out there that was different, just to poke it for guiding, that program would not exist. So the people who try to get into this and close things out and do one, be the one all size all fits all, eventually they get left in the dust. And I could tell you some stories about this that have already happened, but I'm not going to do it because all I can say is this scenario has already played out in astronomy in a couple of spectacular fashions.
Dozens of times.
So
again, we're not trying to start anything here.
Right.
I mean, it is a conversation that a lot of the consumers have. And I almost want to say to the manufacturers is to take note of what it is that the consumers are wanting. It is not a particular product, and we have to go down their road. It is an open source community. And I think that's where ASCOM ALPACA really has stood up against all of that and said, look, this is an interface that can work with any system. And I think that's a critical part. And the more these guys work with the idea of this, the better it is, again, for the end users, which is, again, me, because I am an end user, believe it or not. I don't just sit here buying this stuff and just staring at it all day long. But yeah, sorry. I know we're digressing here, but carry on.
Yeah, that's okay. So let me get myself I need to give you a status update on Alpaca. So where we are now, we kind of went over some of this already, so this is good. It's well known. It seems like people just know it, and a lot of people were spring loaded to. They already wanted something like this. The protocol specs are all done. They're published. They're there. If there's any change to any of the abstract interfaces, that is the definitions of the objects and actions, they will be made both to the COM side and the Alpaca side simultaneously going forward. So you can be sure that you won't have a disconnect between the two. That is compatibility is the number one thing with ASCOM. ASCOM Platform 6.5 is in the process of being released. It's days away, if not maybe a week. And it has Alpaca and the gateway that I showed you, the magic yellow triangle with the two-sided arrow, that's built in now. And Simon mentioned the Optech focusers, and I mentioned planetarium programs. There's an industrial grade Astrohaven controller that is being used in a couple places now that speaks Alpaca. It was built out of Beckhoff industrial controls things, and it's just brilliant. I mean, it's in a couple of the big university observatories that our DC3 Dream software runs on, and it's just amazing. And again, we didn't have to change anything. Nobody had to change anything on the Windows side. So that was cool. And one other good success story is, I can't say who it is or who it's for, but a major government lab has a big project involving space that they had designed all their own REST protocols. And when they saw Alpaca, they threw it all out and adopted the Alpaca because they said, this is just perfect. So that's now well underway, and it's a big success story early on for the technology. As far as where it's implemented on hardware, the Alpaca protocols, the REST endpoints and things, and also the discovery protocol that's used by Alpaca to find out where devices are on the network and what their addresses and ports are without you having to type a bunch of mumbo jumbo in. That's now running on all these different type of devices here. And the code base is being migrated away from the .NET platform. .NET platform to .NET Core. So a lot of the tools can be run on other platforms besides Windows. .NET Core is aimed at being totally cross-platform. What's not cross-platform is the GUI, and that's a whole nother story. Which of the 7 GUIs on Linux do you want to use? Anyway, the tools, the libraries, and all of that are already ported to some degree and are continuing to be so. But the Alpaca protocol and the discovery protocol have been implemented on little things like a Node MCU and other things. So it's well along. I mentioned the chooser. I'm almost now to the end, and I'm almost to the end. So I mentioned the chooser. I don't know, all of you probably have interacted with the ASCOM chooser, but I'd like to point out in 6.5 that it has a new menu here, the Alpaca menu, and an indicator. So if you have Alpaca devices out on your local network, remember I said it's for a sterile environment inside a local network, not the worldwide internet, you can ask it to discover, and it will then populate the device selector here, which currently would only contain the drivers for the various device types that you have installed. Now there'll be some new entries for the Alpaca devices, no matter where they are. They could be running on a Raspberry Pi or what. That'll populate this selector box. And then when you select that, the platform will build a stub driver, a COM driver for you on the fly. This is new. So for example, if you have an imaging program, MaximDL, and it wants to use one of Optech's focusers, which is reachable only through Alpaca and Wi-Fi, you can discover it and then select it in the chooser. And what the platform will do for you now is it will build a stub driver so that you, on your end, MaximDL in this case, don't need to add any new Alpaca code. You talk to the stub driver and that converts from COM to Alpaca, and you see that Optech Alpaca focuser exactly as if it were plugged into one of your USB ports and running the COM driver. No difference. So it's really cool. There's a lot that's already been done. It's well underway. And this is part of Platform 6.5. This thing over on the right lets you set up the discovery, which you only would have to do once. And it's shipped in such a way that it will work on most people's system without even opening that thing up. But you can get to that with this other these other menu items here. So what can you do to help? Now this is pretty much wrapping it up now. You can encourage, to answer your question, what are the migration paths? What are the migration plans? We're way ahead of the curve as far as the technology base that's supplied by the ASCOM initiative. It's out there, it's ready to go, the tools are there, the documentation's there. It's now up to the app and the device developers to jump on this and start using it to extend the reach of universal connectivity beyond Windows. But that's who has to do it. So it's up to you to encourage those people to let them know, I'm interested in this. I want not to have I hate a USB. Can you make a focuser that just speaks Alpaca or whatever? So keeping it vibrant, open to innovation, using standard interfaces, as long as you think that's a good thing, and I'm hoping I've convinced you that it is by now, you can encourage them to adopt that. Also, I have to say this, although it doesn't pertain exactly to Alpaca, there's nothing worse as an app developer, and I'm speaking for myself, but I know I speak for other people. Don't ask us to create software victories over hardware. In other words, ads, doodads, and things. And well, first of all, you're not going to be able to do it because the interfaces are not designed for applications to make up for defects in devices. So you're going to end up asking the app developers questions they don't want to answer. They don't want to be embarrassed, or they'll have to give you a negative answer, and that creates friction. Just understand that app developers are not in the business of making your cheap hardware better. If you want better hardware, buy better hardware. If you have something that's giving you limit that you're seeing the limitations of, well, live with the limitations, or go back to the hardware guys and say, you know what, your driver or your motors or whatever, you need to do something better with this. That's fine. But the people who build the applications that use this stuff are not part of that equation. And just so you know, and I know Simon knows this, and I'm sure he's dealt with this issue exactly over and over again at Woodland Hills. And finally, give it time. If it's not going to happen overnight, because all of this involves your vendors, your application and your device vendors taking risks. What we've tried to do is minimize the technical risk. The biggest risk is designing your own protocol. And the next biggest risk is designing your own connectivity. Well, connectivity is either Ethernet, TCP/IP, or USB, right? So that's off. So that leaves the protocols and the interfaces being the number one risk in a modular system design. We've taken that risk away because we've proven to the world that those interface designs work, and that 100% of our respondents said that they would take those interfaces, would take them into the future. So what more do you want? Nonetheless, these people have to take a risk. They have to decide to put up their money and their time to develop something new, and then hope that somebody will go out there and buy it. It's free enterprise, right? So that's what has to happen for this to continue. And you're the key. Being a consumer, you've got to go over to Woodland Hills and buy this stuff when it comes on the market. If you say you want it, then go get it when it comes out. And that's going to be the number one deciding factor on how fast this gets adopted in the market. So this is my ending master question and answer session time. I went only 4 minutes over, and we used a lot of that to talk about,
I know we
stuff.
were venting for a brief moment there. I mean, like I said, for a lot of the vendors, and I do talk to the vendors on a regular basis, so I do know what's going on in the underside of the astronomy world. And, I do like to single these people out on purpose because it puts them in a bad situation. I have no fear of doing that. But the idea behind doing it the way that I do it is so they can understand that this is what the audience as an end user actually wants. There is nothing more irritating when I am on the phone, email support, or whatever method of communication that there has, is I'm constantly fighting with a system. And I'm just sitting there going, you know what, if I can do half of these things, just like what Alpaca was showing, I mean, in the last 2 slides with the auto discovery, I cannot wait for the day when I can just go over somewhere and just press that button, do the auto discovery and say, okay, we're up and running. All you got to worry about is taking the damn picture or moving the scope. And that's what it should be.
It is. And that's why our fight is so often with people who want just the opposite. It's the difference between this world, which a lot of these gadget lovers, they want more dials, more knobs, more switches, more poking, prodding, and these people who just want to get in and drive.
Yeah.
And that's where we're going.
Right.
The second one.
This is the point that I've made for all the vendors out there is there are more people that do not want to press buttons and dials than there are people who do want to press buttons and dials. I mean, I show people EQ mod all day long when they buy certain mounts, and they look at it and they freak out. And I said, don't freak out. You don't need to worry about any of this stuff. This stuff is still ASCOM at the end of the day. You just need to do this and then this, and it will start working. Don't worry about the rest. That's
Yep.
the idea behind it.
Feature creep.
Yeah.
It's and that's what we fought bloody battles against feature creep in the interfaces for ASCOM. And I will say I was on the front lines of that. And I'm having been an interface designer and an interface negotiator in a previous life. I managed to keep things clean in that regard.
So let's go back to a real question.
Okay. But you know what? I want to say one thing, Simon,
Sure,
before that,
sure.
while it's still on my mind before I forget. You at Woodland Hills play a vital role in this ecosystem by taking the input from the customers, because you deal directly with end users. So you know what the real situation is. And by feeding that up the pipeline to the product developers, you're an absolutely essential piece of that puzzle. So I just want to let you know that by being engaged and understanding, and I have to say, I've dealt with other commercial enterprises where the salespeople are pretty clueless, the most recently being Tesla. Man, when I bought a Tesla, and man, what an experience that was. Those salespeople didn't know anything. The guy gave me the car and said, here, drive it. And he didn't even give me the fob. So I'm halfway out in a driving rainstorm, and I look down and it says, don't stop. If you do, it won't start again. I'm like, oh my God. So it was quite an experience. Anyway, you guys do really well. I'm really impressed. So that's a compliment.
I will make that as a point, is you also have to expect more from the vendors as well when it comes down to this. Now, incidentally, I do like to push this back onto the people that produce the product. There is only so much support that we can give as a retail outlet. And even though it's not really our responsibility to provide the technical support, it's been an asset for everybody that we do know what we're doing. I mean, this is one of the things that I've always found difficult, is when I buy anything, forget astronomy equipment, it's just anything in general. When I buy it from somebody, there are two major factors. Does the person who's selling it to me know what they're talking about, or will the manufacturer stand behind it?
Right.
And this is the way that I treat everything else, and even other vendors. If you don't support me, I will not support you. And it's sometimes it's quite obvious that I just simply just turn around and say, I'm not going to make any comments about that particular product. They know what I'm talking about.
Well, I've had a pretty good career as a application software developer in astronomy. It's run now for 22 years. And we made a very nice business of it.
Hold that thought, because that is going to be my ending question. Okay.
Well, I want to tell you this has nothing to do with ASCOM. It has to do with me and our company. And what I started out, because of my past, I knew that software is a service business, not a product business. So to this day, I spend 4 to 6 hours on our communication center or on the phone with people, assisting them in various ways, trying to help them achieve their goals or work around problems with equipment. A lot of it, USB is the big one. They turn, and I could go on and on about it, and I don't mind, because they pay me. I actually have a recurring service charge for support, and we get paid, and we have a nice business out of it. We are able to keep our house payments and all that. So the deal is, by doing that, I've kept customers for a long time, and they're very happy, and they're getting what they need to get out of the systems. And I don't mind helping them solve problems with equipment, because I'll gather the data, put the package together, and then send them and my analysis off to the equipment manufacturers. And then it's up to them to solve the problem, because I can't, because I know nothing about the equipment, right? I just know how to identify where the problem is. And this does involve ASCOM. By having the universal interfaces, it's much easier for me to determine where the problem is.
Right, exactly.
That's it. What I said about that slide where, if I support 1,000 different kinds of mounts and only one's misbehaving, Where's the problem?
Right, exactly.
So,
All right, this is an actual question. Do I have to worry about 6.5 being buggy, and should I wait to upgrade? I already know the answer to that.
how can I answer that question? None of us would purposely put out a buggy piece of software. That's my answer.
Mm-hmm.
You know, it was out in RC for 6 or 7 weeks.
Mm-hmm.
We got a couple of little wrinkle things, nothing that died or anything. And so it's being released right now. And as far as we know, there's no problems with it. But how can, when somebody asks you, is your software buggy? What do you do? I mean, it's like, did you stop beating your wife? I don't know how to answer that question.
I'm going to interject into that one. There's one thing about astronomy that I've noticed. If you ever see an update, always install it. It's not an update because, oops, we screwed up and we fixed something. It's more of a case of, hey, there are improvements, just like what 6.5 is. It has improvements that you should always look into. Unlike other companies, cough, cough, I'm not going to say their name, but you're probably using their software right now. They tend to release things that are just full of issues. They don't care what happens. They just have a deadline because they got shareholders. This is the beautiful thing.
They don't take care of customers. They don't
interface
with customers directly. And there's a big list that ASCOM people can get on and ask for help. And you can see the posts that are on there. And that's how you find out what went on with the art release candidates. And there was a couple, I think, but I don't know how to answer the person's question beyond that. I do put out updates for bugs. And what I will also, because I'm not perfect, there's no bug-free software in the whole world. And you cannot anticipate everything, even after all this time, where you have an infinite number of combinations of equipment and people and missions. You're going to come up with stuff that you know, well, I can't, you know, so, but I always try to send them a solution right away and then queue it for the next release. And so the next release is always a combination of features that people have asked for and things that work better because people have asked for fixes. So I do that, and I, you know, there have been several updates to the ASCOM platform, and the whole damn platform will be re-released if a little thing is found. So
of course. Answer to the other
tended
question. And I love this saying: if it's not broken, don't fix it. Again, that is an interesting statement that I've always come across. I will say this: if you didn't change anything and everything is working, then of course do not play around with it, because for all you know, you could install a new piece of software, new driver, whatever the case may be, and you got problems. That's the beauty behind what ASCOM does. Is when there is an update, it's not something's broken. Let's give you new features. Let's start implementing these new things. If you're not ahead and you're not with the game with all of this stuff, you will not be a part of any of this stuff. So when you're asking things like Alpaca, but you don't update because you think it's going to break something, then you won't be a part of the actual bigger picture.
This comes from people who have had bad experiences with software in the past, and I understand that.
Totally.
And Microsoft being a perfect example. You know, you'll put in a new Windows and then boom. But so I get it and I understand that, but I also get periodically somebody will say they'll run into a problem, and I'll go, you know, you need, and I already know you need to be running the current version because that came up 3 months ago and I fixed it immediately and it's now in the current version. So, you know, you will need to, there's nothing that ain't broke. There's nothing out there that ain't broke.
Right.
And so, because the whole thing changes, you know, somebody makes a change to their focuser and it acts different. And then my assumptions, I don't know how to explain this. It's in a complex system with a bunch of moving parts, things can change and expose a problem that you didn't see before. And if that gets exposed and fixed and you don't fix it, then you're going to get bit by it too. And then you're going to end up with the company telling you, oh, you're running old software.
Right.
Well, you know, I just never change it because if it ain't broke, don't fix it. Well, okay, I understand that and I sympathize with it. I am compassionate with people who have had a bad experience. So I will usually try to be as nice as I can and say, well, you know, if you update, then it'll be cool.
Well, I mean, interesting thing here is I'm actually helping a gentleman right now who has just purchased a new mount and a telescope. And I will admit one thing, he is using older archaic software. And incidentally, his system is an older system. The thing here is, though, the learning curve, and I think this is what the real fear is, not the software, it's the learning curve. The fear is that with these people is they're not used to the new way of doing something, therefore it doesn't work, or there's something wrong, or there's this issue, or there's that issue. Again, going back to your Tesla picture, this is the picture perfect method that we're all trying to work to, is to get rid of this spaghetti mass. And it's not physical hardware of cable spaghetti mass. We're talking software integration spaghetti mass. That's what we're trying to get to. And that's the part, again, drives me nuts when I'm trying to sell a product. I know what the customer wants. I know what they need. I know how they're going to do it. It's there also is the overcoming the fear of what is new. The vendors have to overcome this fear, and so does the consumer. I welcome this with open arms, because obviously I'm selling a product, but I'm also the end user.
But it's important to know that the developers, both the developers of the devices and their drivers, and the developers of the applications that you use, nobody can test with Windows XP anymore.
No, of course
we
not.
We don't ever test with Windows XP. In fact, a lot of the things that go in to our software weren't available on Windows XP. Right. They just came along 5 years ago, something happened, and oh, this is a great thing. We can take advantage of this new technology. It gets built into our software, and then Uncle Festus pulls his ancient laptop XP thing out of the garage and tries to run the software on it, and it doesn't work. And they're like, this stuff's crap, you know? So it's a problem with old, crufty computers and things. It's a
modernization.
And you can tell I'm not very sympathetic to that, because, you know, skin flints and things, it must be tough. I take my hat off to you. I support people, and again, I try to be as compassionate as possible, but man, it gets old sometimes. Because all I want is my customers to be happy and productive. That's it.
Okay, so here's the surprise attack on you.
All right.
You're not just famous for ASCOM. I will say that. There is something else you're famous for, I guess, to a lack of better description, is obviously your other primary company, DC3. More importantly is ACP. What is with all these acronyms?
Astronomy, ACP started out as, you think Richard had a huge task to try to dig through the sky in an hour. I would have a huge task trying to dig through the software that I have in an hour as well. But I do have the elevator explanation, and that is ACP stands for Astronomer's Control Panel. It was my first software in 1999. It was a graphical user interface to the LX200 Classic. It quickly morphed into a more general purpose system and had the ASCOM interfaces added to it as I developed ASCOM and put them in there, and so it morphed and it became an automation tool that would interface with anything through a declarative plan, not like CCD Commander. You tell it slew here, do this, do this, do this, do this. That's what I would call a procedural plan. Yep. What a declarative plan is: here's the filter, here's the interval, here's the target coordinates, take 10 images. Here's the blah, blah, you know, and then with variations. So it's declarative. It tells what you want, not how. And then it's up to you to figure out when and what. So that's ACP. It does the how. Then the next thing that came along in 2006 was the scheduler. And what it does is it gets rid of the when. You basically put into the scheduler everything you ever dream of imaging for a year if you want. I mean, if you've got the time to pound all that in, fine. And then it starts up and looks at everything that's in there, figures out what it can do based on moon distance and filter and distance above the horizon. Is it visible? How far above the horizon is it? Do you want it up near the meridian? Things, what the conditions under which you want that image to be taken, not the time, the conditions. It looks at all the stuff out there and the conditions you specified and figures out right now, what can I do? Then it looks at all those and makes a tricky decision. What should I do? And then it goes and does that. Maybe a half hour, an hour later, it comes back. It's done that. And it goes right back through the whole thing. Now, an hour later, what can I do? What should I do? And then it works for a while. And it does that all night. And if the weather stops you, it just puts your observatory on standby. And then, when the weather gets better 2 hours later and all the things you were working on 2 hours before are now down in the west and way out in the west or whatever in an unfavorable position, but because you told it everything you ever wanted, it goes and looks, oh, I can do this now, boom, and it starts up. And this all came from someone asking me, well, do you have a way for ACP to pick up where it left off after a weather interrupt? Well, no, because everything's out of position. So then it just goes downhill from there. And I did the research and just developed a general purpose thing for that. So that's what we've been selling and supporting. And we just call it an observatory operating system. And so that's what I do for a living.
So again, for those people watching at home, how do they find that software? And
dc3.com. That's it. https://dc3.com. I didn't put it in here because I didn't think you were wanting me to talk about commercial stuff.
I thought I'd surprise attack you on that one because again, a lot of people don't know ACP, and I hear a lot of people say SGP all the time. Because this is for the hardcore users out there. ACP actually is a really good tool over something like SGP. I'm not going to turn around and say who's better versus one.
It's also way more expensive. It's incredibly expensive. So, we address a different segment of the market from SGP, and I don't want to take anything away from those guys. They did a wonderful job on that software. I talked to them, like Richard was saying, we're all friends anyway, right?
Yeah,
so
this is the beautiful thing that the group that I have today, hopefully, are going to be some of the harder hitting guys that really have something to look at or have an observatory and want a better solution. Again, this is not who's better than the other guy type scenario. This is more of a case of if the actual product suits your purpose, then at the end of the day, honestly, people need to look at ACP. I do actually know people who use it. So, and they've showed me.
They're out there. We have over 1,000 users and probably a few hundred active remote users, remote observatories. And one of the things that I didn't mention, which I should, is for educational and government use, it comes with its own web server and content. Mm-hmm. And so you can have people use the observatory without giving them access to your observatory computer through remote desktop or whatever. You basically fill out a form and then push it into the system and you get your images later by Dropbox. So it keeps the students from going in and changing dials. I don't know, we were talking about that before too, that people want to go in. Bruce was saying how they want to dial around on their gain and things on their guider. Get it working and leave it alone. And it's the same thing with ACP. You'll get a team of people who will be using the observatory. I have one night, you have another night. Well, you don't need that with a scheduler, right? Everybody just puts their stuff in there and it gets it when it can. But let's say you don't have the scheduler and you get one night. Well, the guy goes in and, Uncle Festus said I need to dial up the gain and turn down the this, that, and the other on the guider. And then the next guy goes on there. What the hell happened to my guiding? That's a big problem. And so the web interface keeps people off of keeps the hood closed on the car, so to speak. So they're not in there changing the spark timing and mixture. And then the next guy gets in and the thing drives like a dog, right? So that's another thing.
Excellent.
I could go on, but I don't want to chew up everybody's time on my stuff.
Yeah. No, we can actually, I wouldn't mind doing a talk on ACP because I get a lot of people that do the observatories. In fact, some of the observatories do watch this live stream on a regular basis. So again, I think I need to pull you back to do something for those guys. I do need to do something specifically for the observatory. So again, if you guys who are watching the stream, even live or in the after show or whatever the case may be, and you operate an observatory, and when I say observatory, I'm not talking about a great big dome in the middle of wherever, or the Palomar Observatory. I'm talking if you have a permanent setup that has specific functions and requirements, feel free to reach out to us, because we will work with you in multiple ways, not just with equipment, but we can also point you to software and things like that. Bob?
So getting back to the last slide here, this is the ASCOM website. There is tons of information on here. I'm showing right now the developers page for Alpaca, but there's all kinds of end user information, and there you have it. I mean, this is it. So, and it's going to be revised in the next few weeks. When 6.5 comes out, then that'll be my big job. I'm the keeper of this website. So again, I'm not a developer, but that's my little contribution. So it'll be changed to reflect the 6.5 and the fact that you don't need ASCOM remote unless you want to reach in to Windows from the outside. And that is it. That's pretty much the whole thing. The URL at the bottom is ascom-standards.org. That is where everything takes place. On the main page, there are links to the two actually, groups.io groups, one for developers and one for end users looking for help. So there's a help group and an a developer group, and that is very active. So I better not try unsharing my screen, because then people are going to see I don't know what. So
yeah. No,
I don't have my browser open. So.
That's all good. All right. So it's now 4 o'clock. I think we're going to call this for now. We will probably have another live stream sometime towards the end of this month. It's more about photography. I have somebody from Fuji Films talking about Fuji film itself, as in like 35mm negative film. I also have a wedding portrait photographer. Mac Murdoch is also going to be coming back, talking about his experience with using the camera. So it's going to be a Fuji film day, I think, for the next one. And then after that, depending on the availability, we're either going to do solar in different bandwidths, not just hydrogen alpha. There are other bands that you can look into. So
that's cool.
Hopefully, keep your eyes peeled, subscribe to our live stream, and as soon as it comes out, you'll get the notification. Don't forget, we have 10% off on the QHY-CCD cameras, plus the PoleMaster and their mini guide scope. It's 10% off. You've got to use this promo code. Obviously, this is not going to go on forever. I think it goes on for 2 weeks, so you guys got 2 weeks to react to all of this. And my cat wants to get fed by the looks of it.
That's cute. Simon, thank you very much for having me on.
Thank you.
This was so professionally done. And I want to also compliment both Bruce and Richard for, I watched both of their presentations, and it's great. I really, I don't know Bruce as well as I know Richard. Richard and I have spent a lot of time talking about different things. And Bruce, he and Andy are both, they have done so much for astronomy. I can't compliment them and thank them enough. So bravo to both of them. This was a really good session. You had a couple of really good people on, and then me. And I don't know.
Yeah, anyway. No, thank you. No. You're part of all of this, whether you like it or not.
All right, Simon, thank you so much.
All right, then. So I'm just going to fade out. So again, thank you everybody for coming and watching. We will be back. So we'll see you soon.